our theme today, which is GD&T, geometric dimensioning and tolerancing. So I'm going to go through a series of slides, kind of introduce some concepts to you, and then we'll be working with the software itself. First of all, MBD, model-based definition, defines the product and marketing information, the PMI of a product. And the idea is to have a single source of truth. The MBD process starts with an annotated 3D model. The 3D model replaces the 2D drawing as the PMI, while it still supports 2D processes. So you can still take and do the front view of the 3D model and the end and the top and all of those views, and those 3D annotations that you have created can then be displayed documenting the model if you did want to create a drawing, let's say for a customer or something like that. Traditionally, 2D drawings kind of were the definition of a product, and they're really the legal asset of that product. Before 3D CAD, 2D was the standard format and really the main deliverable that engineering would provide. There are still many processes that are based on 2D drawings today, like inspection. And in order to replace the 2D drawing, all the information needs to be included in the 3D part. MBD does just this. So the question is, why continue using a 2D drawing? So MBD reduces waste. It decreases lost time and effort by not having to create a 2D drawing. Typically, it's been the rule of thumb, as long as I've known it, that you spend about 40% of your time creating a 2D drawing, aside from creating the geometry itself. You can minimize rework and reduce any of the out-of-sync data, and there is no real need to track any additional assets. In addition, it reduces errors due to misinterpretation, and 3D models are just a lot easier to understand visually and easier to interrogate. As I was mentioning before, it saves a lot of time. This is some feedback that we got from our customers. It's 40% faster in documentation creation. Again, I was saying about 40% of your time is going to be spent making a drawing. We can eliminate that. 60% reduction in first article inspection, and then 90% product 90% less non-conformance issues with a product. So it's faster to develop, it's faster to manufacture, and reduces errors. In this case, we see an example down here of a component, and if we saw this in a 2D drawing, unless it's particularly spelled out that it's a through-all hole, it could be misinterpreted, but in a 3D model, there's no question at all that we can see that it's a blind hole in this example. So GD&T Advisor, that's really what we're going to be talking about today. It's a spell checker for creating GD&T. So why do we need something like this? A lot of companies struggle in adopting MBD standards and learning to keep up with the latest standards. That can be daunting. You can lose time debating the right way to apply a GD&T, and you can go through multiple cycles reworking them. There can be an increased manufacturing cost from errors and due to misinterpretations of improperly applied GD&T. And tolerance errors can also lead to scrap, rework, and confusion. So engineers, when they're using GD&T, they just want to be able to speed up the process. And this is a way of breaking down barriers on the engineering, the design side. We're creating semantically correct standards. And by semantic, I mean that these GD&Ts are applied to certain surfaces or holes or things like that. So if the surface changes, the hole changes, it is linked to that particular GD&T. So there's an intelligent link between the two. We can create and validate GD&T semantics using expert recommendations and tooltips that are built in to GD&T Advisor. And we can also apply interactive GD&T help content. So if I have any questions, it gives me any errors or any informational things, all I have to do is double click on it, and it will give me the information as to exactly what I need to do. On the company side, at a more global level, we can eliminate barriers for MBD implementation and basically gain the benefits that we saw before in the previous slide to support downstream activities and reduce the errors that we talked about earlier. So this is a view of the GD&T interface. Those of you that are familiar with Creo will usually have the model tree along the left side of the screen. Here we're going to see a feature tree, which is basically the geometric tolerances that we put on. And then down below that is this advisor tree. And the advisor tree tells us as we're going along, if a surface is constrained or the GD&T is correct. It'll tell us if there are any surfaces that are left to be done to be constrained. And it'll show us even in colors, things that are fully constrained, partially constrained are yellow, unconstrained at all are gray, which is the default color typically for Creo. And then also we can also constrain surfaces by a profile tolerance. So there's a lot of different feedback that we can get from GD&T Advisor to make sure that we're creating things correctly. In fact, when I pick on a surface or a hole, depending on the geometry I pick, it will tell me what type of tolerance GD&T to use. So if I pick on a surface and say, okay, maybe this is your first GD&T, so it's a flatness, and I'll highlight it here in green. These are your choices that most logically will apply to the geometry that you selected. And it actually looks at the geometry and the GD&Ts you made previously and also works off of those to saying this is most likely the accurate or the most advisable way or at GD&T to place and put in there. So it's giving you throughout the experience the correct things to do, and it leads you down the path. You don't have to be an expert, and that's really the whole idea. There's also extensive help. So, sorry. And the help will give us information. As I mentioned before, we can right-click, we can double-click on information in the advisor tree, and it will bring us information exactly, not only what's wrong, but what we can do to fix that. And we'll see that in the demonstration. There's two different flavors of GD&T Advisor. There's the basic version, and that one will allow you to do and place GD&Ts on models. It will look and build things according to the different standards that are out there. So ASME ISO standards. And then it will also give you any warnings if things are not exactly as those standards state. There's an advanced version. The advanced version allows you not only to do it on parts, GD&T, but also on assemblies. And it will also work on existing things. So GD&T typically works like spell checker in Word. As I'm typing things in, it can be correcting me or highlighting things that are misspelled or underlining things that might use a different syntax. So that's the way GD&T works. As we're putting in our geometric tolerances, it will look at those and tell us what to correct as we're adding them in. Well, the advanced one allows us to take an existing drawing that we've created and kind of runs this spell checker on it. So it looks at the GD&Ts that have been created and then tells you if they need to be fixed and then how to fix them. So it isn't kind of an online real-time thing, but it can be kind of a post-processor for existing drawings, which can be pretty useful. So kind of to summarize things, we can increase engineering productivity, reduce product development costs, reduce manufacturing costs. That's the whole idea behind the GD&T Advisor. So with that, I'm going to get in and start working with the geometry and give you some examples of how to create geometric tolerances using the GD&T Advisor. So it is an application, just like many of the other applications inside of Creo. And all I have to do is select on that, and it brings it in. Now it does put in, here we have a couple of default, basically just pulling out some parameters of the part. So default notes that are here. So the thickness, this is a, technically a sheet metal part. So it's putting that in there. And it's showing us what standards we happen to be using. So we're using ASME standards right now. So I'm going to start off, and here's the ribbon interface. So very easy to use, very easy to understand. You spend most of your time just basically using this left icon. Down below, we'll see this is where our tolerances will be displayed, and then any errors or informational messages. So I already have two to start out with. That's saying not all the degrees of freedom are constraining the surface. So it's just like assembling a part. We need to constrain this part in 3 degrees. And then also some of the surfaces are not of the design are not constrained. So we can see that here. So let's start off by using this. I'm just going to come over, select on this, and I'm just going to pick on this top surface. And it comes over here, and this is where the semantics comes in. This is the surface that this geometric tolerance will be applied to. And so I'm going to say, yeah, okay. And it brings me in to the ribbon. And this is the ribbon interface. Really nice the way that it highlights things in yellow that need to be filled in. You'll notice that this, I could check this, right? Even though it's a yellow check mark, it's just saying you're checking it, but there's going to be a warning. You're going to get a warning down here saying that it's not finished. So it highlights the things in yellow where we need to enter information. Here's the flatness. It's chosen that by picking that flat surface, and it's, you notice it put a little star there. It says most likely this is the GD&T you want to apply here. But you could also do profile of a surface. But you notice the others are grayed out. So it's really narrowing down my choices on what to use. So I'm going to come over here and say, let's put in a tolerance. So I just type this in. As soon as I hit return, you'll notice that the yellow goes away and the green, or the check mark is now green and not orange. That means this is valid. So I can come in and say, let's check this and put it in. And we can see over here in the feature tree, here's our geometric tolerance. We can see it here in 3D. And we can see, and if we needed to move it around or place it somewhere else as we're putting other ones in, we can certainly do that as well. So let's move along and put in a couple other ones and see some other benefits of using GD&T Advisor. So we'll go over here. I'm going to pick on one of these holes. Again, it selects the surfaces of the hole. I'll say, yep, that's what I want. Brings me into this. And now here it's showing me the dimension for this hole. So 170. I'm going to come in and just select on this dimension. And then I can specify, just like we can in regular Creo, we can specify the type of how we want this to be displayed is either with plus, minus, symmetric, nominal limits. So I'm going to just say plus, minus for this. I'm going to bump it up to 3 decimal places. And I'll just come over and enter in some values here. And we'll say plus or minus, oh, +2, -1. So we put that in. We can see it visibly up here as it's starting to build this. Now it's picked perpendicular. So we've already picked a flat surface. So we picked a hole on that flat surface. So it says most likely you want this hole to be perpendicular to that. But it could be angular, right? Potentially. But you notice it puts the little star next to perpendicular. So now we want to put in a tolerance for this. And we'll just say, 2000s. Again, when I hit enter. But now in this case, because we picked a hole, it wants to know, do we want to use maximum material conditions, minimum, do we want to use regardless of feature? I'm going to say, let's use, because it's a hole, we'll say maximum material conditions. Because you notice, unless we put one of these in, it still stays orange. So I'm going to say maximum material conditions. Now we know that this is good. And I'm going to put this in. So now we can see it's automatically applied this. It's calling it datum B, as it's the second one in here. We see that it's maximum material conditions and all the information that I placed here as well. Now there's 8 holes here, you can see. So one of the things I can do is I can select on this, and just like in detail mode, we can come in and say I want to add something here, and I'm just going to say that there's 8 holes, and maybe place that in the middle. So we've added that information in here, and we can say let's update. This is sort of like the regen of GD&T. But it updates it. Now it did put in a message here saying that it's saying that this text that I put in here isn't referencing all the other holes. And if I double click on it, it says typically that's okay, right? But you could go and reference the other things. So that's just, it's just an I. It's just telling me this is just for information purposes. we have this. So the next thing I'm going to do is let's look over maybe on the side, put in another tolerance down here. I'm going to pick on the cylinder. Again, it's grabbing the holes for this. We'll say, okay. I'll kind of rotate a little bit so we can see this a little more clearly. In this case, for a cylinder, I'm going to say, let's use plus minus again. And we can say, bump it up to 3. So you notice that, I forgot to increase the decimal place. It automatically flagged it and said you're typing in a third decimal place when you only have 2 specified. So this is giving me some really good feedback as I'm going about creating this. And we could, let's tighten this one up a little bit. We'll just say plus or minus 1 on this guy. And we'll say, okay. So you can see that again displayed up here. Now we do the tolerance for the diameter. So again, I'll just say it's maybe 2/1000ths. Because it's a hole, I'm going to say maximum material conditions for this guy. Now I might want to put in another tolerance as well. So I can come over here and say, now it picks parallel. So by looking at the other things, and this is really considered a orientation tolerance, but I'm going to say it's parallel to A. So it's automatically found that. And I can put in a tolerance for this. So I'll say it's 2/1000ths. In this case, I'm going to say regardless of feature. And now I can place this. Comes in, puts in our tolerance. So I'm taking a look at this. Now I have an error message down here for this tolerance that I just put in. And it says the orientation tolerance must be smaller. I can double click and it tells me exactly what's going on. And it tells me what to do. So either the orientation, that second tolerance, needs to be smaller than the tolerance above it. So I can either make the top one bigger or the bottom one's smaller, but otherwise it will be incorrect. So in this case, I'm going to kind of just make the top one, but we really do the one whichever one is probably cheapest to manufacture, my idea. But I'm just going to come in and add a decimal place just to make this a little bit bigger. And now when we kind of update things, the error message goes away. And in this particular case, we could also come in here. Since there's a hole on this side and there's the exact same thing over there, I'm just going to come in like I did before, and we could just say this one is in 2 places. And place that in as well. So on the side over here, and it does recognize kind of more intelligent things about parts. So this hole happens to be a pattern, as the one on the top was not. If it was a pattern, it would have grabbed all 8 of these. But this was just, these were just put in as separate holes. But in this case, I'm going to come in and say, let's create GD&T on this hole. And it automatically said, I see a pattern, do you want to apply it as a check mark? And I just took the default, yes, apply it to all of these guys. So here's our dimension here. And we're going to take him. Let's move him over a little bit. There we go. In this case, we're going to add, like we've been doing, adding some tolerance. And this time, let's say it's symmetric. We haven't done that yet. We'll give it a general tolerance down here. We've been doing 2/1000ths all day, so we'll continue with that. And again, I'll say maximum material conditions. You notice it's automatically put maxes on both of these other ones as well. So I didn't have to do that. I didn't have to think about it. It's just according to the standard. That's the way that we do it. Again, I'll hit a check mark. We've got our tolerance in here. Everything is looking good. One other thing is, again, this pattern of 8 holes exists on the back side. So I'm just going to add another option in here just to say that that's also in 2 places. And again, that's going to give me another informational blue icon down here, just letting me know that, that it's just an informational type thing. So I can say, let's update this. So everything is good to go. I can check this by showing the colors. Remember, I talked about this a little bit earlier, that will highlight things in green that are fully constrained, things in yellow that are partially constrained, and things that are gray are not constrained. So I still have this warning. Remember, I had two warnings at the beginning. One was that it's not fully constrained. Now it is, right? Because the flat surface constrained it, this hole constrained it. So basically it can rotate about that hole. And then by picking either one of these holes, that constrains it from that rotation. Those are the three locations, three constraints. And so now it's locked in. But it's still saying that some of the surfaces are not constrained. And I'll double click on this. It's like, well, what do you need? Double click, and it says there can be added some geometric profile tolerances to other surfaces. And it's telling me 3 steps that I need to do in order to do that, in order to fulfill this need and to erase this little warning message. So at this point, after I read in those 3 steps, what it basically says is go into properties of this thing. And I'm going to add in a general profile. And I can take this and add in a tolerance. So I'll say 2000s. So it's going to apply that profile tolerance to all the gray surfaces. And I'll say, okay. So now they turn blue. And that warning message went away. At this point, I'm finished. Everything is in great shape. I can send this to inspection, to manufacturing, and I'm not going to have somebody coming back to my desk yelling at me that this was GD&T was incorrect. I know that everything is right. It's very simple to do. It was checking me the whole time. Anytime I had a question, I double click, it lets me know what to do. And I've created a fully documented GD&T representation of our part. And now we can go in and go into manufacturing. So GD&T Advisor is a really easy tool to use. It keeps up to date with the standards, and it makes sure that everything you do is correct. So you can be confident that the things that you've done, it's a one-time deal, right? This is correct. I'm not going to have somebody, coming back. They might ask me to change a tolerance, for manufacturing reasons, but the GD&T itself and the way that it's laid out is exactly the way that I want it to be. So that's really where I wanted to go with this today.